PWM stands for pulse width modulation. It's a digital way to control things like brightness of an LED or DC motor speed. Now we will create a new project, an STM32 based PWM. So let's get started. Now we will select our controller for this project. Here we are using STM32 F103C6 for Proteus Simulation. We will name our project here. When we talk about the PWM on STM32, here is the cool part of these microcontrollers. Just fantastic. They come with really powerful and super flexible timers, and it's, to be honestly, those timers are absolutely essential for us to generate our PWM signal. So our timer peripheral frequency is currently running at 8 MHz. So for that we will generate 1 kHz PWM frequency here. So here in timer section, so we'll select timer 1, and then we need to click select clock source. So we will go with internal clock source and then select channel 1 here, and it will be automatically enable PA8 pin on STM32. Alright, with everything is configured, so we now need to actually start our PWM timer. So let's call the HL time PWM start function here. Here we have to pass function arguments, so like timer 1 and channel 1 is our arguments. So inside our main while loop, so that's our continuous loop, and we are writing this for loop. So it's a set of have our variables I start at 0 and it's go up to 1000, and it's increment by 2 with every single iterations. And now inside for loop we are calling HL time set compare function. So here we are passing arguments our timer 1, PWM channel, so channel 1, and it's our variables I. So after first loop we will add another for loop, and this one is the reverse, and it start at 1000 and it's count down by 2 and all the way until I reaches 0. And inside this loop we will again call HL time set compare and passing our timer, channel and variable I as arguments. all rights with our code all set up, and now final step is to generate hex file and run the code and to simulate on Proteus software. Here now you can clearly see the output. LED brightness is gradually increasing, and after some time it start decreasing, and we can look this on oscilloscope also. So let's see, we will observe exact behavior of PWM waveform in oscilloscope.